Assalamu alaikum everyone, hope you're all fine and welcome back to my channel. And today we will talk about central processing unit architecture, CPU architecture, and that is the registers. And our today's discussion is to give you an understanding of the purpose and the role of register, including the difference between general purpose and special purpose register. All right, so let's start. So the registers, when we talk about the registers, these are actually the high speed storage areas in the CPU. This is the simplest thing that you should need to understand, that the registers are the high speed storage areas in the CPU. All right. And we can categorize them into two major types. One, special purpose registers, and the second category is the general purpose registers. The special purpose register, I'll explain it before the special purpose. We'll talk about the general purpose registers. The general purpose register, these registers hold the data that is frequently used by the CPU. So the general purpose register hold the data that is frequently used by the CPU or can be used by the programmer. All right. And then the very common example of the general purpose register is the accumulator. This is the one very common type of the general purpose register. And what this register, this accumulator register, it does, this register stores, just a minute, this register stores the value before and after the execution of instruction by ALU. So when any kind of instruction is being executed by the ALU before and after, it will be stored into the accumulator. So this is the general purpose register. Then the special purpose register. In the special purpose registers, these are the registers What is their job? These registers have a specific function. Specific function within the CPU and hold the program data. They hold all sort of data and the addresses. Okay. Now the example, like here, the example of the general purpose registers, they are CIR, IX index register, MAR memory address register, MDR, PC, and SR. So this is the current instruction register. This is the index register. Index register. This is the memory address register. And this is the memory data register. Program counter, and then this is the status register. All these registers are placed in the category of the special purpose register because each of this register has a special role in the processing of the data. All right. So you can also understand it with the help of a diagram, that the registers, how they work. Let's say this is the CPU, and this is the memory. So program counter, MAR, MDR, CIR, the ALU, this is the accumulator, and this is going to be control unit. So I made all these here. So this is the program counter, MAR, then this is the MDR, CIR, accumulator, this is CU, and this is the ALU. I draw the ALU like this always just to give the reference of its role in the processor. ALU is the section that performs all arithmetic and logical operations. So all these boxes, these white boxes, these are the registers. So as I mentioned, and these are the special purpose register. So these are the special purpose register, and there is only one general purpose register. All right. So program counter is, now what is the job of program counter? Program counter is the register that always contain the address. For example, I show you the memory part, the IS, where we have the addresses 101, 102, 103, 104, 105, 106, 107, 108. This is, let's say, a sample data, LDD 106 at 15, store at 108. So this is these are the addresses, and this is the data part. So program counter contains the first address that is to be, which is, so program counter contain the address. All right. So store the address where the next instruction to be read can be found. So what the program counter, so we can say that this, I'll just program counter, what it is doing, store the address where the next instruction to be read can be found. So this is number one. Then MAR, what the MAR does, MAR, it stores the address of the memory location. It stores address of the memory location currently being read. Currently being read or written to. So that is the MAR. Then what is the MDR? Memory data register, also sometimes called as MBR, memory buffer register भी कहते हैं इसको. It stores the data. All other registers, PC and program counter, and the MAR was store the addresses, and it stores the data which has just been read. Which has just been read from memory. All right. So it will have the, so what is, it will have the data against the address which was in the MAR. Then the CIR, it stores the current instruction. It stores the current instruction being decoded. And executed. All right. So these are the registers in the CPU. So this is the CPU and this is the memory, IS or RAM. And in the next topic video lesson, I will tell you about the buses. So how these buses they are. So this is about the, and all right, one more, that is the status register. And what the status register is doing, it's not mentioned here. Status register is has a different role than the general purpose register. The status register contain bits which can be set or cleared depending on the operation. All right. It can be an overflow in a calculation like that. So this is about the registers, and I hope you people are clear about it. So today we learned the role of the register and with its different types. Okay ji. So in the next lesson we'll talk about the buses.